Hello, this is our first presentation on thunderstorms. And we're going to start out by discussing thunderstorm definition, the definition of thunderstorms, and then work our way into the required conditions for thunderstorms. So first, what exactly is a thunderstorm? If you look at the Federal Meteorological Handbook number 1, the definition of thunderstorm is a local storm produced by cumulonimbus clouds that is accompanied by lightning and or thunder. It doesn't really say anything about rain, hail, or anything else. It's just if there is lightning and thunder, there's a thunderstorm. So thunderstorm by itself will be reported at a station if thunder is occurring at a station. And that's within 5 miles of the station. If there is precipitation occurring with a thunderstorm, then that will be reported. And typically during the summertime, you see a thunderstorm with rain. Thunderstorm, here you see plus TSRA. The plus qualifier is for the rain. So in this case, it's saying that there's a thunderstorm with heavy rain. If there was a minus sign in front, it would be a thunderstorm with light rain, and nothing indicates a thunderstorm with moderate rain. You can have thunderstorms with other types of precipitation. This METAR is pretty interesting. It came from Hot Springs, Arkansas in the spring of 2016, and it shows thunderstorms with freezing rain and also mist. So thunderstorms are reported in the main body of the METAR if the thunderstorm is occurring within 5 miles of the airport. And I use the reference here ARP, or Airport Reference Point, which means typically the place where you make weather observations. And if that does occur, they'll also put in the cloud section CB. They'll annotate that or add that to the lowest layer of cloud. And then also, if they know the direction of movement of the thunderstorm, they'll put that in the remarks section. Here you see thunderstorm overhead moving to the east. If thunderstorms are occurring between 5 to 10 miles from the airport, not right at the airport, but around its periphery, then they'll put VCTS to indicate thunderstorms are in the vicinity. Okay, now let's take a look at the required conditions for the formation of thunderstorms. You probably remember this from private pilot days or from your 110 class, your atmospheric science 110 class, that the required conditions, there are 3 of them, moisture, instability, and lifting mechanism. A lot of people don't realize that there's a 4th requirement for severe and long-lasting storms, and that is strong shear. So we'll take each one of these one by one. Let's take a look at moisture. When we are looking for moisture for thunderstorm development, we're talking moisture at low altitudes. Typically thunderstorms are rooted at the surface. Not always are they rooted at the surface. Sometimes they are lifted aloft and you're looking for higher level moisture. But most conditions, usually you're looking for low level moisture. And the way you look for moisture is by measuring the dew point. So here is a particular day. This is the 20th of May 20th of May 2013. And across the southern plains of the United States, across Oklahoma, you can see, and I highlighted in green, the areas where dew points were in the 70s. So places in northeastern Oklahoma, the dew point was 72, and Arkansas was 72 also. And then along the Gulf Coast, you can see it's in the 70s. Much of the region also had dew points that were in the 60s, and then it starts dropping off as you move across West Texas. You can see they drop off pretty quickly into the 50s and 20s and even into the teens. So dew points in the 50s and 60s and even 70s means that you have enough moisture for thunderstorm formation. 70s is very high, 60s is pretty good, and 50s is pushing it. The other thing that you look for the development of thunderstorms is instability in the atmosphere. And the way we measure instability is by looking at the environmental lapse rate. And there are a few things that we can do, a few places we can look at. One is the sounding. So let's take a look at the sounding first. This is the sounding for the 20th day of May 2013. And you can see that if you lift a parcel from the surface, first it lifts dry adiabatically. And since the air is very moist, dew points that are in the 70s, it saturates very quickly. And then it follows the pseudo or saturated adiabat, or sometimes called the moist adiabat also. So the parcel is rising. The parcel temperature cools at the saturated adiabatic lapse rate. Now you compare that with the environmental temperature as measured by a radiosonde, and that's indicated by the red line. And you can see that the parcel temperature is always warmer than the environmental temperature. If that's the case, that means that the parcel will continue rising all the way up through the atmosphere. In this case, it's forecasted, the parcel is forecasted to rise all the way up above 2,000 millibars. And you know that 2,000 millibars is approximately 39,000 feet. So this storm continues to rise well above that. And this is a very unstable storm. This is a stability indice known as CAPE. It's convective available potential energy. And what it is, it's all the area that is outlined by the rising parcel. In other words, this is at every level. If we add up the amount of energy between the parcel temperature and the environmental temperature, and we do that all the way up to the top of the atmosphere, this is the amount of energy that's available to be released by that parcel of air. And usually we look for thunderstorms when the CAPE value, the convective available potential energy, when CAPE is greater than 400, 500 joules per kilogram. In this case, across Oklahoma on this day, you can see that CAPE values are extremely high. 4,000 joules per kilogram. That is a very unstable situation, as indicated by the sounding. We saw that it rose all the way up to about 39,000 feet and then more. So on this day, there's plenty of instability. And then the third thing that we look for thunderstorm formation is a lifting mechanism. And it can be anything. It can be fronts, heating of the surface, convergence down low, anything to get the parcel of air rising. And on this particular day, the 20th of May, 2013, we see that there's a low pressure system located across the Dakotas with a cold front dragging all the way down through Oklahoma. And that cold front associated with a weak low across Oklahoma and also a dry line through Texas kicked off storms on this particular day. The fourth requirement is for severe and long-lasting storms, you need wind shear. And we're talking about vertical wind shear. As you go up through the atmosphere, the wind direction and wind speed change with height. And on this particular day, the 20th of May, 2013, you can see that the winds start out from the south at the surface and then switch around to the southwest and increase in speed. And then finally in the jet stream levels, you have a pretty strong jet stream at about 75 or close to 80 knots. And then that shows up on the weather maps also with southerly flow across Oklahoma, bringing up moisture from the Gulf of Mexico. Here's 925 millibars. You can see the winds are still out of the south across eastern Oklahoma. They start to switch around a little bit, and here they're kind of veering a little bit to the southwest. That was 850. This is 700 millibars, definitely out of the southwest at this point across Oklahoma at 30 knots. And then you can see at 18,000 feet, the jet stream starts kicking in with winds that are approximately 65 knots. Then finally up in the jet stream levels, 300 millibars, the winds are moving at a pretty good clip at 75 or more knots across Oklahoma. So on this day, the 20th of May 2013, the Storm Prediction Center made a forecast of moderate risk for severe thunderstorms across Oklahoma and Missouri and parts of Texas and Arkansas. And by the afternoon, this is the 21 Zulu radar mosaic across the United States. You can see a line of thunderstorms developing out ahead of that cold front from Kansas down into Oklahoma. So by the afternoon and evening, the Storm Prediction Center put out a tornado watch box for eastern Oklahoma. And on this day, there were severe thunderstorms with tornadoes across much of the Midwest, stretching from Oklahoma all the way up to Michigan. And this is the day of the Moore tornado that killed many people and damaged many homes. Specifically, it flattened a school in the middle of the afternoon, and children were hiding in their hallways trying to protect themselves from the tornado. That's all I have for this video. The next video will cover the climatology of thunderstorms.